Okay, so we're going to go ahead and we're going to finish up ellipses here. So in this video, we're going to do where we're given pieces of the graph itself and then having to write it into standard form. So right here, I'm given one where I have vertices at 6, 13, 6, negative 11, 9, 1, and 3, 1 for my co-vertices. All right, so what I'm going to do is I'm going to go ahead and graph this. Now, I can already see that this is going to go off my graph because my graph only goes to 10. So this is negative 11, then this is 13. So what I'm going to do is I'm going to count each unit here as 2. So here I'm going to go 2, 4, 6, and then I'm going to go 2, 4, 6, 8, 10, 12, 13. And then again, I'm at 6, and I'm going to go 2, 4, 6, 8, 10, 11. Alright, so those are my vertices. My co-vertices are at 9, 1, so 2, 4, 6, 8, 9, and 1. Oh, sorry, I did that up too. 2, 4, 6, 8, 9, and 1. So be right about in the middle of there, and 3 and 1. Okay, so I'm going to go ahead and draw my ellipse. Alright, so what we have to figure out here is exactly how to do our equation. So whenever we're writing these equations, I need to know what h and k is, I need to know what a squared is, and I need to know what b squared is. So I can go ahead, since I have vertices and co-vertices, I can tell what my h and k is just by looking here at 6 and 1's here. So 6 and 1 are my h and k. And I can go ahead and confirm that here, 2, 4, 6, and F1, that's halfway between each of these. So that's my center. Alright, so now we've got to figure out what a squared and b squared is. So in order to do this, since I have gone ahead and figured out where my center is right here, I can technically go ahead and count on my graph. I can go 2, 3. So right here, if I started at my center and I go to my co-vertex right here, I would be going 2 and then halfway, so 3 units. So that's going to be, I shouldn't do it, I shouldn't do that. We'll do it as b equals 3. So if b equals 3, because I'm counting from my center to my co-vertex, that's 3. So that means that b squared is going to be 9. I can do my vertices. I can go from my center and go 2, 4, 6, 8, 10, 12. So that's going to be my a equals 12. So it means a squared equals 144. I can also do this by going from vertex to vertex. If I didn't know what my center was, or co-vertex to co-vertex, I could count. So I could go 2, 4, 6. So from co-vertex to co-vertex, it's 6. So that's 2b. So half of that would be 3. Likewise here, I could count from one vertex to the other, and I could go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that would be 2a, and then half of that would be 12. So it just kind of depends upon what makes sense to you if you're drawing it. Then right now I can go ahead and throw this all into my equation. So I need to determine if this is going to be x squared over a squared, or if I'm going to have the y squared over the a squared part. I got to figure out which equation I'm going. So where's the a squared going to be? So the a squared is my biggest number, and that means that my displacement here is going to be from my biggest number is going to be going vertically. So that means it's going to be underneath the y squared. So I'm going to do x minus h, which h is 6, squared, plus y minus k. Oops, helps if I write the y. y minus k, which is 1, squared equals 1. And I'm going to have my a squared underneath the y. So that's going to be 144. And here that's going to be 12. Okay. Let's try this one down here. We'll do this one without graphing. So if I'm doing this without graphing, just like what I had mentioned before, if I have a graph and, I don't know, let's do it like this. So from here to here, these are my vertices. This whole thing is 2a. So I have those points right here. I have my vertices. And then I also have my co-vertices, which would be from here to here. And this whole thing is 2b. So it basically means what I'm saying here is from vertex to vertex, I have 2a. So here we're going to work with a. So in order to solve for that, I have to find the difference between the two. So that's going to be 8 minus negative 8, right? And that's going to go ahead and turn these into plus, which is going to say 2a equals 16. So then I'm going to divide by 2 to both sides, and that gets me a equals 8. So then a squared equals 64. All right. And then I can go ahead and do 2b, since I know that that's what this is going to be. My x's are not changing, only my y's are. So I need to figure out the difference between the two. Remember, difference means subtraction. So I'm going to subtract the two, so it's minus a negative, that becomes a positive. So then I'm going to have negative 3 plus 17, which is going to get me positive 14. So that's 2b. So then a is going to equal 7, which means that a squared equals 49. So again, I need h, k, a squared, and b squared. So I have, oh, I just noticed I wrote those as a. Sorry. These are b. Right here, I apologize. So I have both b squared, I have a squared, and then I've got h. Oh, goodness. It's really late at night. I have h and k right here. So then I can go ahead, write my equation. So I've got x minus h, which we know is going to be 0 squared, plus y minus k, which is negative 10, so plus 10 squared. You know it equals 1. So now we just got to figure out where the a squared is going to go, so the bigger number. So if I look at this, if I was to graph these, my vertices would be changing on my y, just like, or I'm sorry, on my x, just like how my co-vertices were changing here. So if those are changing on my x, that means I'm going to be going side to side. So that means right here, my vertices changing side to side, that means that I'm going to be underneath the x. So my larger number here, my smaller number here. Now, again, you can always double check yourself and make sure that you're doing this the correct way, just by kind of graphing. If I was to take this whole thing right here and try and graph it from the equation that I have right here, I could go backwards. So if I was to do that, I was going to figure out our center here, if we're doing this. Center here, as we discussed, going from here to here, I've got 0, negative 10. So I'm going to go ahead and go to that location on my graph, 0, negative 10. And then this right here is telling me that I'm going to go horizontally on my x, 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And then this right here is telling me that I'm going to go up and down 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I don't need to worry about graphing the other one, but what I'm trying to show you here is I can go ahead and take these coordinate points and make sure that they match what I originally started with. I was given vertices and co-vertices. I was given these points right here. Do the 3 of those, because I only grabbed 3, do those match what I have right here? So 8, negative 10. 8, negative 10. Negative 8, negative 10. Negative 8, negative 10. And then 0, negative 3. 0, negative 3. So this is how I know my equation was done correctly. Now, these are a little bit more challenging, so I'm going to go ahead and put these in a different video so that I make sure I don't run out of time.